Hello, my mathematicians. This is Miss Foster with a very special look at long multiplication from an extension perspective. In class, you don't have to be able to do what I'm about to show you, but we will do it in class and you can keep doing it at home because the multiplication we're going to do today really helps you understand multiple digit multiplication from patterns, connections, and relationships. We'll be deeply exploring the question, if we understand place value and regrouping, does it matter how big the numbers are that we multiply? Strong mathematicians are thinking about what math means, and that is what this lesson is all about. To create a long multiplication problem that you can really play with, it's a great idea to use dice, and I want to show you how we might do that. So here are my electronic dice, and I got a bunch of them because we're going to want a bunch of digits. There are a lot of digits. I'm going to fill them in here in any order that I want. So I'm going to maybe start with 1, 5, 6, and 3. But I want even more digits in here, so let's try rolling them again. Oh, this is so exciting. We're also going to have 5 and 6. Wow! I have just built the number 653,651. But I didn't use all my digits over here. Let me roll them one more time just for fun. I'm just going to pick 2 of them this time. And I'm going to choose 53. Now, right now you are saying, hey, Miss Foster, my adults and I usually don't put the largest number on the bottom. It's true that what we're about to do will take a lot more writing work, but it's key for us to see how the patterns and relationships and connections with place value and regrouping are used in long multiplication. Just as we would with the multiplication you learned in 3rd grade, we're going to start with the single ones place. And we're going to multiply from the single ones through the tens of 53 to make sure that we don't need to handle any regrouping. So if I start in the single ones place, you can see that we have a single ones column, but we also have a single ones row. And with the single one we're talking about here is this one. 1 times 53. Well, lucky for me and you, that was pretty easy, wasn't it? Let's move on to the tens place and the tens row. This is a step that you have done in class before by now. We're now doing 50 times 53. And this is where we will write the tens multiplication. But notice down here, I have analyzed 50 into 10 times 5. I'm doing that because multiplying by tens will help me if I do it first. Any number that's multiplied by 10 will have a 0 in the single ones place. There are a lot of ways to think about this. If we're multiplying with those manipulative strips like tens, the rods that we have at school, if we're only multiplying those, we won't have any single ones. So I'm going to start with multiplying 10 right there. And then I'm going to do 5 times 53. Again, starting in the single ones place, this single one right here, just in case I have to regroup. 5 times 3 is 15. I will drop the 5 right here because I'm really doing 50 times 3, but I already did the tens part. I'm going to regroup that tens up here because whatever gets from this multiplication place will be in the hundreds. Now you may be saying, Miss Foster, I don't understand how the tens place here will wind up in the hundreds. Here's why. The 5 here, this pink one, is in the tens place. It represents 5 tens. The 5 here is also in the tens place. 10 times 10 equals 100. And any group of tens times any groups of tens will also equal hundreds. So I'm going to do 5 times 5 is 25, plus 1 is 26. Whoa, that even got us into the single thousands when we did all that regrouping right there. Now here's a great reminder that you need to remember to do when we're multiplying multiple digit numbers times multiple digit numbers. You've got to cross out the old regrouping. I'm just going to cross it off like this. And then that way I'll know that I don't need to use that anymore. Now we're moving on to the hundreds place. This is the hundreds column, but down here it will be the hundreds row. We'll be doing 600 times 53. But once again, I have analyzed or factored 600 into 2 of its factors, 100 times 6. And I'm going to actually start by multiplying whatever 6 times 53 is by 100 by writing a 0 in the single ones place and a 0 in the tens place. As I showed you before, I'm crossing these out because they're kind of placeholder zeros. So I'm letting you know that that's where we're multiplying by 100. Now that I've done that, I need to do the 6 times 53. 6 times 3 is 18. I'll drop that right here in the hundreds place because 600 times 3 would be 1800. So if you really think about it, it belongs there. I'll trade up the 10 hundreds into what will now be my single thousands place. But how, Miss Foster? Check it out. 100 times tens would be single thousands. And look, place value and these zeros are organizing us, so we're right there. 6 times 5 would be 30, and 30 plus this one will be 31 thousands. Whoa, look at that. The next place over and down is the single thousands place. Before I get to multiplying this, I'm going to cross out my old regrouping so I don't get confused. Now, this will be the single thousands row, and it says here 1,000 times 3 times 53. We're literally going to do this 3,000 times 53. But once again, I will divide 3,000 into two of its factors, 1,000 times 3. And once again, I will multiply whatever the product of 3 times 53 is by 1,000 first. And that means that I will go ahead and put zeros in the single ones, tens, and hundreds places because we won't be using those. Dude, we're multiplying those big single thousands, or the purple single thousands chips. Now I'm ready to do the part of this that is 3 times 53. 3 times 3 is 9. Oh, no regrouping on that one. 3 times 5 is 15. And I can handle my grouping right where I put the 15 into its spots. My goodness, we're doing so much multiplication. We've got 2 more whole places to go. We are moving on to the 10,000s place, which will literally be 50,000 times 53. Once again, I have factored out 50,000 into 10,000 times 5. And I'm going to multiply whatever the product is of 5 times 53 by 10,000 first by putting a 0 in the single ones place, in the tens place, in the hundreds place, and in the single thousands place. Now, if you need a visual on what 10,000s look like, they're those huge rods we have made out of origami cubes in class. So huge. Now that I've multiplied this by 10,000, it's time to multiply the 5 times 53. And do you want to know something? I have already done this. Here's a great trick. Right here, when I was doing the tens place, I had to multiply 5 times 53. Which means I already know what 5 times 53 is. It's 265. You're totally allowed to go back and steal this thinking that you already did. My heavens, will you look at that? 50,000 times 53 is 2,650,000. Whoa! But we still have one more place to multiply. Wow, we're going to multiply 600,000 times 53. Just as we have a column for the 100,000s, we've got a row for it too. Way down here at the bottom, I'm running out of room. And this is the 100,000s row. Once again, I have factored 600,000 into 100,000 times 6. To multiply any number by 100,000, we would have to have, let's see, how many zeros? 1, 2, 3, 4, 5. Now, as I write these zeros in here, are you noticing any patterns? Your parents and I agreed that you should probably not do this kind of multiplication because we're writing out all these zeros and boy is it taking a lot of time. But I want you to practice with some of these problems so that you can see the patterns and really appreciate them. All right, there's my 5 zeros. Now it's time to do 6 times 53. And whoa, would you look at this? I've already done 6 times 53. It's 318. So I'm just going to use that thing I already figured out and these zeros to put everything into the correct place, where I discover that 600,000 times 53 will be 31,800,000. Wow! To help us out, I've scrolled down a little bit. Let me review. We've multiplied the single ones on this row, the tens on this row, the hundreds on this row. the single thousands on this row, the 10,000s here in this row, and the 100,000s on this row. We've used a lot of patterns of zeros and the secret codes they represent to tell us about place value. What I did here is I used analysis. I took this incredibly big number, 653,651, and I broke it into smaller pieces to make the job easier for me. But since I've broken it, to get to the final product, I have to put it back together. And that's what this addition sign is for. So let's go ahead and add all of our columns together to find out the final product. It's always so much fun to show you this because it looks so complicated. And yet look in the single ones place. 3 plus all these zeros is 3. Doesn't that feel kind of fun? Here in the tens place, it's 5 plus 5 plus all these zeros is 10. I'm going to use that regrouping I learned in addition and subtraction. There's my regrouping for those 10 tens, which are now hundreds. Little more complicated here. 1 plus 6 plus 8. I prefer 6 plus 8 to 7 plus 8. 6 plus 8 is 14, plus 1 more is 15. Going to have to do some addition style regrouping now again. Ooh, here we are. Do you see how 9 plus 1 in the single thousands place equals 110? I'm going to trade those right now for 110,000 and just cross them off so I know that I've already added them, which leaves me with 1 plus 2 is 3. Ooh, in the 10,000s column right here, we have a lot of numbers to add. But I'm always looking for friends of 10, and I know that 5 plus 5 is 10. 10 10,000s would be 100,000, so let me get rid of those and just do that regrouping, leaving me with 1 plus 3 is 4. On to the 100,000s place. Once again, I've got 1 plus 1 plus 6 plus 8, 4 different numbers to add. But I know that these make 2, and that 8 plus 2 is 10. So I'm just going to get those friends of 10 right out of there and regroup the 10 100,000s into one single million, leaving me with 6. Ooh, I do enjoy column addition. And now look, in the single millions place, 1 plus 2 plus 1 equals 4. And in the 10 millions place, 3 plus nothing equals 3. So we have found that the product of 653,651 times 53 is 34,643,503. Whoa! What patterns might you have seen in this method of doing it? Here are some that I see. I notice that I used columns right up here for place value, but I also gave each place of value its own row. I notice that I've got a pattern here of zeros, that these patterns of zeros helped me to multiply things by whole powers of 10. By tens, by hundreds, by single thousands, by 10,000s, and by 100,000s. And that I was able to use that to leverage place value to organize every single digit into its place. By doing that, each time I multiplied, I really did multiplication that you learned in third grade. For example, 6 times 53, let me show that to you. In third grade math, you learned how to do 6 times 53 like this, down here. And that's not too hard for you. You already know how to do that. But I'd like to show you at least some of these problems every year, because if you really understand place value and regrouping and patterns of zeros, it doesn't matter how big the numbers are that you multiply. To play this at home, grab yourself some dice here, roll for a super long number. You can go as big as you want. Put a 2 or 3 digit number on the top and the long number on the bottom, and see if you can multiply by huge numbers. Thanks for playing math with me, guys. I love playing math with you. Bye-bye for now.